So one thing about solving radical equations, which is what we're going to talk about here first, it's very important, if at all possible, that you get the radical by itself before you try to solve. So for example, super simple equation here. What if we have the square root of x is equal to 5? How would I solve that? Square both sides, okay? So the square undoes the square root because they're reciprocals. So that's essentially what we're going to be doing here. Now, looking down at number 1 real quick, what do you think is going to end up happening in number 1? At the end. Like, we had a square root on the, or a square on the square root of x. How do you think we're going to get rid of a cube root? We're going to cube it, okay? So you might see a cube. You could see a fourth, a fifth. You could see a 10th root. How do you get rid of a 10th root? The 10th power, okay? Now, using what I have up there at the top, to solve an equation, we want to get the radical by itself if possible. On number 1, what do you think we would do first? Add 15. Okay, now, all the other rumblings that are going on right now, we need to stop. This is a long lesson, okay? It's not tough stuff, but it's just going to take us some time to go through it. I can't keep stopping to get you to be quiet. All right, so we're going to add 15 to both sides. I do not need to see you physically write plus 15, but if you need to do that, then do it, okay? All right, now this goes all the way across the 1 here. Okay, what do you think we would do next?
Divide by 2.
Divide by 2. Now, you cannot divide or multiply or divide inside a radical unless you're dealing with another radical, and I don't have that going on. So do not try to put that 2 inside. Divide it to get rid of it. Okay. Now, what do? We're gonna cube both sides, not cube root, because I'm trying to get rid of the cube root. So cube both sides. Now, I'm going to go ahead and write that just because that's a little bit weird. You do not have to write this step, though. But make sure that you do the cube correctly. The cube's going to get rid of the cube root, okay? And then 5 to the 3rd power, make sure you do 5 to the 3rd, not 5 times 3. That's going to be 125. And then it's up to you how much work you need to show from here. Some of you don't need to do a -1 and then a divided by 2. Again, it's up to you. I'm going to go ahead and do the -1 because I don't have my paper with it all worked out here. Then divide by 2, I get x equals 62. Now, technically, you should take that and plug it back in, but we're only going to have a couple where that's really going to be an issue, and we'll look at that when we get down to example 3. Okay? Questions there on the first one? Okay. So second one here. Now, I told you that we should try to get our radicals by themselves. I've got a problem because that 3, if I get rid of that 3, I move it to the left. Now it's on the left. I can't get rid of it, okay? I can't put it inside, so it's just there. So I'm still going to square both sides, but I'm going to end up having something like this to square. How do I square 3x? What do I get?
9x squared.
9x squared. You have to square the 3 and the x. So when I square this, and I'm just going to go ahead and put it on the actual problem here. When I square both sides of that, obviously the left's just going to be 7x plus 2. On the right, I have to square the 3, which is 9, and then I square the square root, which is 3x minus 2. Now, you don't have to necessarily put it in a parenthesis, but that 9 is going to have to be multiplied times that whole parenthesis. And if you don't do that, you might only multiply the 3x. So I would suggest a parenthesis. Okay. So go ahead and multiply it through here. That's going to be 27x minus 18. X is on one side, numbers on the other. Now, some of you are going to just go ahead and tell me the answer at this point. All right, that's fine. But this is one of those things that on this test, a lot of this is basic algebra stuff, okay? So some of you are going to end up kicking yourself in the butt because you tried to do it all in your head and you made a mistake. So show a few more steps, okay? I like to get all my x's positive, so I'm going to move the 7x to the right. So that's going to be 2 is equal to 20x minus 18. Move the 18 to the other side. And I get x is 1. Now, the whole thing about not skipping too many steps, I did that on one of my examples here, and the first period caught me on it. I made a mistake. I skipped the steps. I tried to do it in my head. I left out a negative, okay? The more steps you show, for the most part, the better. Okay, questions there on 2? Now, you know that sometimes we have questions where we get answers and we plug those answers back in and at least one of them doesn't work. Sometimes that's going to happen. For us, it's really going to happen only when we end up with more than one answer. So that's when you'll know that we might need to try to plug these back in. So that's going to happen here on example 3. Now, unfortunately, example 3, if I go to get that radical by itself, I cannot move that 5 inside. I'd have to move it to the other side by subtracting. So that's going to look like this. Now, when I go to square both sides, I have to square x minus 5. Now, this is where some of you need to stop doing this stuff that you've been told years ago not to do. When you square x minus 5, you cannot just square the x and square the 5. Now, that's different than up here, okay? Up there, I can square the 3 and square the x. They're multiplied together. When things are added and subtracted, you can't just square them in pieces like that. So when I square this, okay, this is what I'm doing. X minus 5 squared is the same thing as x minus 5 times x minus 5. So if you want to write that out as 2 parentheses, that's fine. Otherwise, I just need to make sure that when I'm multiplying this that I'm actually really physically squaring it. Now, I've told you this before, there's a shortcut to that. So when I'm squaring in the x minus 5, I'm squaring the first, I'm squaring the last, you multiply in the middle and double. Now, I don't want that to have to be something that you're memorizing to do. If you don't remember how to do it, just write it out. Okay, so you're going to take x times x, you're going to take x times negative 5 times x, negative 5 times negative 5. Okay, but you cannot just square the x and square the 5. Now, this is kind of something that was concerning about yesterday, and it wasn't just this class, it was all the classes. When you were doing that question number 1, you had a quadratic, and you were struggling with how to solve that. You've got to know how to solve a quadratic. Okay, 2 big things solving a quadratic: factor or quadratic formula. That'll work. Quadratic formula works in every case, but that should be a last case scenario because that's kind of a complicated method. So C, can I maybe factor this? Well, to do that, everything has to be on the same side. So move the x, move the 7. This section of problems that we're going to be doing here in these 4 lessons, there's a lot of quadratics. So you've got to know how to solve one. Okay. Everything onto one side there gives me x squared minus 11x plus 18. I can do factor or I can do the quadratic formula. Totally up to you. This one, though, is pretty easy to factor. So we're going to factor it. What are 2 numbers that multiply to give me 18 that add to give me negative 11? 9 and 2, but they have to both be negative. Now, it doesn't matter which order you write them in, but do double check before you keep going that when I multiply that together, I do in fact get x squared minus 11x plus 18. And then break that apart. I don't need to physically see you break it apart, but solve it there. We end up with 9, and we end up with 2. Now, we're not done because we've got to check those answers. It's possible one of them may not work, but any questions up to that point? Now, I'm going to physically show you where I'm plugging them in. I don't need you to do that. Some of you are going to be able to plug them in your head and see if they work or not. So down there at the bottom, you can see, take the original equation, okay, and I stuck 9 into it. That's going to give me the square root of 16 plus 5 is equal to 9. That's probably enough for you to see that that works, but just in case, 4 plus 5 is equal to 9. Yeah, that one's good. Okay, now, you do have to try both of them because it's possible they may both work. Don't assume that just because the first one worked, the second one's not going to. Ladies, up here. Plug the 2 in. Okay, so now 2 plus 7, that's going to be the square root of 9, plus 5 is equal to 2. Now, that square root of 9, it's a positive square root of 9, which means 3 plus 5 is not equal to 2. So my only answer is 9. Now, why does that happen? Why do you get an answer that doesn't actually work? Well, if that square root of 9 was able to be a negative, which of course sometimes square roots are, you would have had a negative 3 plus 5, which would have given you a 2. Now, I know that's kind of tricky because sometimes, I'm on you about, make sure, don't forget, when you do a square root, you got to do a positive and a negative. That's when you decide to put it in. If it's already there, you do it the way it's written. This is written as a positive square root, so I do a positive square root. Okay, questions about that? We're kind of getting a little bit more complicated as we go along here. All right, this is the last radical question, and it's the most complicated. You can probably tell there, it's just one question on a page. Okay. Now, the problem with this is, again, I'm trying to get that radical by itself. I got to move that 2. Well, if I move the 2, I just move it on the other side, and it's equally going to be a problem there. And this is not like logs where I can easily combine 2 radicals together if I move the radicals on the same side. So I'm just kind of stuck. So we're going to square both sides. Now, when I do that, obviously the left's not going to be a big deal. The right's going to be the big deal, okay? When you square the left, we just get 4 minus 2x. Now, when I square the right, I don't normally write this out like this, but I'm going to in this case because it's more complicated. This is what's going on, okay? Now, you can do the shortcut with this. This is like, on the front, the x minus 5 squared, okay? I'm going to square the first ones, I'm going to square the last ones, I'm going to multiply inside and double. And if you can do that as a shortcut, that's fine. This one, though, I think is a little bit more complicated. So multiply this together, okay? 2 times 2 is 4, no big deal. Now, when I take 2 times this, okay, pretend that this is just an x. So 2 times x is 2x. This is going to be 2 times that radical. And it'll be negative because I took a positive times a negative. So, sorry, not positive. Minus 2 radical negative 3x. Okay, 2 times that radical is 2 times that radical. Negative, again, because there was a negative there. Inside, same thing happens. I'm going to take a negative radical times a 2, which is going to be a negative 2 times that radical. Now, at the end, okay, so we're going to take this times this. Now, if I were to take a square root of 3 times the square root of 3, what do I get? 3. It's really the square root of 9, but it simplifies to 3. So because they're both the exact same radical, the radicals cancel out. So that's what's going to happen here at the end. I've got a negative times a negative radical, so that's going to be a positive radical. And when I take radical negative 3x times a radical negative 3x, I get a negative 3x. Now, why is it not a positive 3x? Because it's what's underneath the radical, and what's underneath the radical is a negative. The plus in front is because I took 2 negative radicals times each other. Okay. Okay. That's like the hardest part of this one. Okay. Questions about that part so far? Yeah.
Isn't it negative 3? Negative 3.
Right, but I'm not taking a negative 3 times a negative 3. It's like this right here. Okay, so because it's 2 square roots that are exactly the same, the square root goes away, and I'm just left with what's inside. So what's inside is a negative 3x. I got to keep that negative there. Now, it's a positive because of the fact that this was a negative and this was a negative. So a negative and a negative, that positive that's in front of the parenthesis is because I took 2 negatives and multiplied them. But I'm technically not multiplying the stuff on the inside, which is why it stays negative. I'm just canceling it out because really what it is, when you do this, it's a square. So the square root of 3 squared is just 3. So the square root of, or the square root of negative 3x is just a negative 3x. Okay. That part's a little tricky. All right, now to start solving this, what I'm going to do is I'm going to do what I was trying to do on the front. And I'm going to get the radicals by themselves. But I've got 2 of them. But they're exactly the same, which means I can add them together. It's like I've got a 2x in the middle, 2 2x's. So a 2x and a 2x is a 4x. It's going to be a 4 square root of that negative 3x stuff. So I've got 4 minus 2x is equal to 4. Okay, combine those like terms. A negative 2 and a negative 2 is a negative 4 square root. Okay, and then that plus a negative at the end, I went ahead and just made be a negative. Now we're still trying to get that radical by itself, so I'm going to kind of do some baby steps here. Let's get rid of the 4's, just the constants. If I subtract 4 from both sides, those 4's are gone. Okay. Now let's get all the x's together. So I'm going to add 3x and move it to the other side. Now my radical's not by itself, but it's to the point where I can square it. So let's go ahead and square both sides. I square the x. Obviously, I just get x. So, I'm sorry, not just x. I get x squared. On the right, I'm going to square the negative 4, which is going to give me 16. And I'm going to square the square root, which is going to give me negative 3x. Again, it's still a negative because the square just gets rid of the square root. Okay.
So you wouldn't like divide it by negative 4?
You could. That's going to move it onto the other side, and you're just going to have to square it on the other side. So, yeah. You'll end up with the same answer in the end. Okay. So I've got x squared is equal to negative 48x. And this is kind of what happened to some of you yesterday. You got to this point, and you didn't know what to do. Some of you were trying to divide both sides by x. I can pretty safely say when you're solving an equation, don't ever divide both sides by x. It's never going to be good because you're going to end up losing one of your answers. Okay, this is a quadratic, and I told you 2 ways to solve a quadratic, factor or quadratic formula. Both of those involve getting everything on the same side. So that's going to be x squared plus 48x is equal to 0. Now, if that x hadn't been there in that negative 48x, I could have taken the square root of both sides. Now, not actually because that would have been imaginary, but if it's x squared equals a number, you can do a square root. But it's not equal a number, it's equal a letter. Okay? So everything onto one side. Now, you can do the quadratic formula on this, but guys don't. It makes me sad when people use the quadratic formula on something like this. It's just GCF. Just pull out an x. This is a way of factoring. This is actually the way of you should always try to factor first is using a GCF. Okay, set those equal to 0. I get 2 answers, potentially. I get 0 and I get negative 48. Now, back here, if you had divided everything by x, you wouldn't have gotten 0 as an answer. And spoiler alert, it turns out that's my only answer is 0. So if you divided that away, you now have no answer. Okay, now before we plug those in and check them, I know this was a tough one. This is definitely the hardest that you would have. Questions about those steps there. It's a lot of algebra. Okay, now plugging them in. Again, I don't need to physically see you do this, but you need to do it to see what's going to work here. When I plug 0 in, plug it into the original statement, I end up with the square root of 4 minus 0 is equal to 2 minus the square root of 0. Well, obviously that's just going to be 2 is equal to 2. So that one's good. 0 is good. Okay. Chances are negative 48 is not good, but we plug it in just to check it here. I'm going to get 4 plus 96 is equal to 2 minus the square root of, that one I don't know off the top of my head, 144. So that's going to be 100 is equal to 2 minus 12. Again, if only I could make it negative, but I can't do that. It's a positive square root, so it's 10, not negative 10. So my only answer is 0. Okay, now we're going to switch gears here to fractions in just a second. Questions about finishing out that one there? Okay, so Zach, on yours, you just had it in the multiplying by 16 there.
I
Yeah.
ended up with like 16x squared equals like negative 3x, and then that just gets
Right,
like,
exactly.
so.
Yeah. Okay. All right, now the last part here is rational equations. So this you did definitely in Algebra 2. That may have been the first time, though, that you really did these. So there are 2 good strategies to use when solving fractions. The first one is get common denominators. And for everything, for any constants that you have, any fractions that you have, then multiply everything times your common denominator, and then you're just left with the tops. No more fractions, and then solve. We're going to do that on example 6. Okay. Scenario 2, use common denominators if necessary so that you have one fraction on both sides. And once you have one fraction on both sides, you cross multiply. Now sometimes you're already set up that way. Okay. Now I've only got a couple examples here, so I'm giving you ones that are a little bit more complicated. So example 5. You want to look to see, do I already have something that'd be very easy to get common denominators? Because right now I have way too many fractions going on. So this might be easy for you to see right off the bat, maybe not. So let's go ahead and see if we can factor and see if that brings up anything that'd be easy to get common denominators. So we have a negative 1 over x plus 1 is equal to 1 over 3 times x plus 1. I just pulled out a greatest common factor. And like I said, greatest common factor is one of the easiest ways to factor, but yet it's one of the most overlooked ways of factoring. Look for those. That's going to be a big part of this particular part of the section. Okay. Now, hopefully it's pretty easy to see there that you've got an x plus 1 in two fractions, except one of them is times 3. So it would be very easy to take that fraction on the left times 3, and then now they'll have common denominators. And that's what I'm going to do. But before I do that, I'm going to want those on the same side, and I like to have positives whenever possible. So I'm going to do two things. I'm going to take this fraction on the right, and I'm going to move it to the left, because then it'll be positive. And I'm going to take this fraction right here that's negative, and I'm going to move it on the side with the other x plus 1, so now they'll be on the same side, and they'll be positive. Now, you don't have to do that. You could take that fraction in the middle and subtract it to move it to the left, but then now everything's negative. That's up to you, though, okay? I'm going to, though, flip-flop those two fractions. They're both negative, so to move them, I'm going to add them, and that's going to give me 2 over x minus 4 is equal to 1 over 3 times x plus 1 plus 1 over x plus 1. So, again, I just move things around. Now, I need to get some common denominators, so I'm going to take that second fraction, top and bottom times 3. Now, that is acceptable. You do not have to multiply everything. I'm just multiplying that one fraction, and the reason that that's acceptable is that when I multiply the top and bottom by 3, I'm really just multiplying by 1. So secretly, I'm multiplying everything times 1. It's just that when I take this times 1, nothing changes. When I take this times 1, nothing changes. But when I take this one times 3 over 3, which is really still 1, that's going to be 3 over 3 times x plus 1. Now, I've got one more step before I can cross multiply. I need it to be one fraction equals one fraction. Add those two fractions on the right. I've got common denominators now, so I can do that. 2 over x minus 4 is equal to 4 over 3 times x plus 1. Don't add the bottoms. If I were going to add the bottoms, I could have done that from the very beginning, okay? Because the bottoms are the same, I can add the tops. And then now you cross multiply. Now, reminder that cross multiplying means that you're making an x, okay? So I'm going to take 2 times the 3x plus 1. I'm going to take 4 times the x minus 4. It doesn't matter which side you put where, as long as everything gets multiplied times the right thing. So I'm going to take 4 times x minus 4. I'm going to take 2 times 3, x plus 1. And then we solve that. So 4x minus 16, 6x plus 6. Now, this is the one where I did it all in my head and came up with the wrong answer, but because we're almost out of space here, I'm just going to go ahead and give you the answer. It should be negative 11, not positive 11, which is what I had this morning. But again, show more steps, okay, if you need to. Now, you do have to take a second and make sure that that negative 11 is okay. What is a bad thing to have in a fraction? It's kind of a vague question, but 0, where? In the bottom. 0 in the top's okay, but the bottom is not good. So I do need to take just 1 second and see, will negative 11 give me 0 in the bottom? No, we're good. So my answer is negative 11. Okay. Okay. Questions there on 5?
Why is it negative 11? Wouldn't it be like negative 22?
No, you've got 2x equals negative 22.
Okay,
Yeah.
I was thinking that.
Yeah. Okay, number 6. We're going to do the other method. So in this one, again, go ahead and see if you can maybe factor to see about some common denominators. That's going to give me 1 over x plus 2 is equal to 4, x plus 2, x minus 2, 1 over x minus 2. Well, hey, I see a lot of stuff here that's in common. This one is a good for that first method here because if I take that first fraction times an x minus 2, then it matches the one in the middle. And if I take the last fraction times an x plus 2, then it matches the one in the middle. And they all match. And then I can get rid of the bottoms. Okay. Now you could do this like the one we just did where we cross multiply, but in the end you're going to have your denominators the same to do that. So this is going to save yourself some time. So the first fraction, I'm going to take the top and the bottom times an x minus 2. And again, that's okay because that's really multiplying by 1. It's just kind of a crazy 1. Middle stays the same. And then the last one here, I'm going to take times an x plus 2. Now, it doesn't matter that it's out of order. All the bottoms are the same. Because all the bottoms are the same, technically what I'm doing is I'm multiplying. You know that when you have a fraction in a problem, you can get rid of it by multiplying by the denominator. That's what I'm doing. I'm multiplying everything times x plus 2, x minus 2, which gets rid of all the bottoms. And now all I have is the top, which is a whole lot easier to solve. Now, when I wrote the tops, I left that 1 out because I don't need to write the 1. One thing, though, you want to be careful when you solve this, make sure that you distribute that negative through that parenthesis. X minus 2 is equal to 4 minus x minus 2. Okay. Now, when I move everything around here, again, I'm going to do what I told you not to do because we're running out of space again here. We end up with x equals positive 2. Now, look up at the top. Is 2 okay? No. It's going to give me 0 in more than one place. So that means I have no solution. Now, unfortunately, though, there was no way to know that from the very beginning. Otherwise, I wouldn't have made you go through all that. We had to go through it and realize that 2 was the only thing that would work, but it doesn't work at the same time. Now, you can do this however you want. You can do it at the end or do it at the beginning, but at some point you need to make sure that you know what's going to be unacceptable. 2 and negative 2 are unacceptable for example 6. Example 5, negative 1 and positive 4 were unacceptable. Okay, one more. 7's already worked out for you, but I just want to talk you through it. Questions there about 6. Okay, so for the last one, this one would be good to do either method. I already have common denominators of 7k, so I can get them on the same side, which is what I did, but I wanted them to be positive, or my 1 to be positive. So I kind of moved things around a little bit, but that was just me getting my k's on the same side. Then I went ahead and combined those two fractions together. Then I put the 1 as a fraction so I could cross multiply. Now notice when you cross multiply, you get a really yucky answer. Leave it as a fraction, unless you're told to round. Always leave your answers as a fraction. Is that an acceptable answer? Yeah, 0 is the only thing that wouldn't work. Now you could have also done this using the other method. If I make that 1 be a 7k over 7k, now they all have common denominators, and I can drop that out. And actually, that might seem easier to do it that way. Honestly, I'm just kind of more of a cross multiplication kind of person, so normally sometimes I do it that way without even thinking about doing it another way. So a lot of these could be done more than one way. I've done a lot of examples, but there's a lot of ways these things could work out. So if you come across anything that you're not sure how to solve, make note of it. Show it to Ms. Collins tomorrow. She should be able to help you with them. If for some reason she can't, then I'll help you with it on Wednesday or Thursday.
I think just put dropping out the 7x.
Yeah.
Would that just be like